Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Happy Father's Day to all you fathers, dads, and pops out there, whatever you refer to yourself as. And happy Sunday to everybody else. Hope everybody's doing well. Today was supposed to be the day I released the design portion of the tiling toolpaths video. That video is shot. I'm in the process of editing it for release next week. So it will be out next week. I will have all that done today. It'll be scheduled to go live next Sunday. I had some real life interruptions, what with getting certain things around here done, and it, it just kind of, there was no way I could get it edited in time for it to go live this morning. So I apologize for that. But I think I said I'm going to try to have it done for this Sunday. It just didn't happen. Um, at least anyway, I got my driveway extension finished. So that's one project behind me. So that means I no longer have a 10-yard load of gravel, driveway gravel out in the middle of the front of the house. So that's gone, thank the Lord. Um, the lean-to shed is coming in, do the official countdown here. It looks like 12 days, and I cannot wait. Um, then once that's in, I'll be able to run the power out there, get it painted, then the dust collector and compressor go outside and free up a bunch more room. So my background will be changing yet again. The reason this is narrow casting for the folks in Oregon. And I know I have a few viewers here in Oregon as well. This Friday, I'm going to be in Albany, Oregon at something called the Black Sheep Gathering. Now, this is one of those gatherings for the fiber community. It is a livestock show and auction, and it's for people who are in the weaving, spinning, knitting world. But it's a lot more than that. And I know a lot of people think of this as, oh man, I don't want to go see a bunch of this stuff. But if you're a woodworker at all, you might want to rethink it, because there are a lot of really cool woodworking projects to be seen and kind of mentally copied in this type of a show and sale. There are vendors galore out there with spinning wheels and with looms and with support equipment for those. We're talking weaving benches with a seat on a bearing system that move back and forth. The seat actually slides the length of the bent. You know, I mean, all kinds of really cool things that woodworkers may be interested in. So again, the narrow casting for my friends in Oregon. This is at the Lynn County Expo Center in Albany. Uh, this Friday, Saturday, and Sunday. I will be there Friday. I'll make sure to have a pocket full of stickers. I'll be wearing a logo T-shirt, so if you see me, stop and say hi, and we can catch up and BS. There you go, Russell. Absolutely perfect. I mean, you wouldn't believe the woodworking projects that could come out of something like this. I've had my eye on a few things, and I know my wife wants a weaving bench for her loom. So that's something that I'll be checking out as well. So, let's see. Sam wants to know, when do I start talking about CNC stuff? That's easy. When you start asking CNC questions. Uh, put your questions down here in the chat, and I'll do my best to answer it. So yeah, get on with it. Bring it on. Come on, man. I'm in the process of working through creating the sled and everything I need to go ahead and do my toolpath tiling project. And so that's going to be the focus of next week's uh, video. I've got the design portion and toolpathing portion done. That's being edited right now. Can you request a tutorial video? Certainly. If I've already done it, I'll link it down in the description of this video. If I haven't done it yet, I'll put it on the list. And if there's a lot of interest in it, I'll get right into it. I'm always open to your suggestions. Uh, that's one thing I try to preach here. This is not about me. This is about you guys. And if there's a technique or a portion of the software that you want to know more about, I need to know. Let me know. If it's something simple, if it's something that's rather short that doesn't really warrant its own video, I'll do it live right here. So by all means, throw it in here. Just that's where my ideas come from, is from you guys. So let's go ahead and get into one that is kind of sort of CNC related, not really, kind of, but it's related to 3D printing, which I don't have a 3D printer, so I know absolutely nothing about it. But channel member and friend Dwayne Ruthig wants to know, what's the difference in PLA filaments? Are they the same from Amazon, and what do I need to know? He just wants a simple black to play with on his first print. So if any of you folks have any suggestions for Dwayne, if there is something to words of wisdom or any kind of a recommendation you can give him, by all means, um, go ahead and throw it in the chat. Let's see here. Sam says, I've been trying to create a double-sided project, a 7-inch bowl that's about 1.5 inches deep. I divided this project into 2 portions, the dish portion and the lid. Okay. The lid is where I'm having problems. I'm trying to create a double-sided project lid where it's curved upwards on the inside of the lid and on the top side, importing a 3D file. Okay. Then curving the lid on the top side and putting the 3D design on the top. Now, let me ask you this about that. You said something here uh, about importing a 3D file. Is this your design, or is this already uh, is this your design, or did you purchase a design? Because the 3D model, if you purchased one, should have it there. It should already be there. Let's see. Let's see, curving the lid on the top side and putting that 3D design on the top. Well, let's play a little bit. Let's get in here and share. And this is what I mean by, if it's fairly simple, we'll figure it out. If it's fairly simple, we'll do it live. Let's go in here to my clip art, and I'm just going to use a something simple, and we'll put a, oh, wait a minute. No, before I do that, I need to go back into job setup and make this double-sided. Okay. And making sure the flip direction is correct. I go side to side. I don't like top to bottom. And I'm going to leave my resolution on standard. Okay. So we'll go with that. Okay. And now I'm on the top side. Now I'll go into my clip art, and let's go with this 60-degree dish. Now we're on the top, so we're looking at the top dome of the lid. Okay. And we'll go over here to the modeling tab and let's make this shape height. Let's see. My material height is 3/4 of an inch. So let's bring this down to 0.7 inches tall to make it a bit shorter of a dome, and close. All right, so over here in the 3D view, we have this dome. All right, now I want to leave some thickness on the inside, some thickness of this lid. Let's make it 3/16 of an inch for the sake of argument. So I'm going to flip over to the bottom and come over here, and I'm going to get this same dome and go into my modeling tab and go into the properties here, and I'm going to make this subtractive. So I'm going to turn that into a dish instead of a dome. Now, my shape height outside was 0.7. So, but I want to, let's go with 1/4 of an inch because that's easier math for me. So I want to go 0.7 minus 0.25, then tap the equals button, and that gives me a dome depth here. Close. And now what I should have is I have the inside of that lid here. And then if I flip over, I've got the outside of that lid here. So if we look over at the bottom, there is the dish shape. And if we look up here at the top, there is the dome shape. And the thickness of the material should be at 1/4 of an inch. Now, something I didn't do was resize it. So the thickness up here is going to be 1/4 of an inch, but down here they're going to be about the same. So I'll need to reduce the diameter of this. Let's go to the bottom side, 2D view, select that, and I'm going to leave, but I'm going to uncheck auto scale Z. And I'm going to, let's just go minus 0.5 equals pi. So that is smaller. So now when I go to the 3D view, there is the thickness of my lid. Okay? There is the thickness of my lid. Now let's see. I've had success with importing the file in and putting it on the lid. However, there's always an issue with the runtime of this project. Would love to know how to do a roughing toolpath, then a finished toolpath for the remainder portion. The project has taken days to complete because I'm using a tapered ball nose for the finish. Okay, well, for that, it's fairly simple. You've got the model here, roughing toolpath, and material setup. That's correct, that's correct, that's correct, that's correct. Okay. We'll use the model boundary to rough the model. And, well, let's change the tool. For this, let's use a 1/4 inch end mill and leave a machining allowance of 0.02. And we'll calculate that. And there is that tool path. Then we'll do for something like this with no real detail on top, I can remove that 1/16 of an inch end mill, and I can do this. Technically, I could do it with a 1/4 inch end mill, ball nose rather. I'll use the 1/8 inch. Make sure that my step over is less than 10%. Select, and I'll use a raster strategy. Calculate. Oh, I've got it no, model boundary. There we go. Calculate. Okay, so I've got that tool path there. Let's close this. Look at the summary. We're looking at 40 minutes of machine time. Now, that is also based on my feeds and speeds here. Now, I do not have very high feed rate going on with this ball nose. In fact, leaving that 0.02 machining allowance, I can speed that up considerably. So I'll go ahead and I'll make it the same as my feed rate. And then recalculate. Then if I look at, it didn't really change this time all that much, but it can change that time quite a bit. So let's see. Don't forget to explain your plan for the rim to fit it into the dish side. That can be done. Let's see. That could be done with a pocket. It could be done. I mean, it depends on what the bottom of the dish is. If the bottom of the dish kind of flares out, the bottom half of the dish kind of flares out, you'll have a little rim to sit it on. And you know, it's 100% up to you. Now, let's see what this will look like, and we're doing the bottom here. So we'll preview all tool paths, and I got nothing. What's going on here? Preview visible tool paths. Why am I getting nothing? Oh, because it's on the bottom and I'm looking at the top. Hello. So there is that tool path there. I have created no tool paths for the top. So let's go over to the top, close, and we'll do the same things. I'll use the same thing, model boundary, yada, 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 calculate, close, then we'll go to 3D finishing, model boundary, use the same things, calculate, and then let's preview all sides so we can get that, see what that looks like. Okay, now I did not do a profile pass, so it did not cut all the way through, but there basically is the lid, the inside and outside. Now, as for your other questions, is it possible to run a tool path for the shape of the bowl, then run another tool path just for the design on top so it doesn't take as long? Not really. I'm assuming you mean a 3D design on top. Okay. A 3D component up here. Once you create that, it becomes a part of the model. Let me zip back over here, go into my 2D view. Am I looking at the top? I'm looking at the top. Now let's go into the clip art and decorative. Let's look for something to throw on top. let's put that on top just for the sake of argument. And I'll hold down Shift, reduce that so that it's right in the center there, okay? So if you're still following me, Sam, I've got these two models. If I come over and look at it in the 3D view, that's what I've got going there, okay? Now, if we look over here in the component tree, I have two components, all right? But once those two components are put into the component tree, this now makes one model according to the software. The software sees this as one model. And you can bake this together to create one piece. Well, it's not actually baking, but we've got that. Click that, and I'll hold Shift and click this. Come up here to model. Let's see here. Create component from create component from visible model. So I click on this, and it is made. I can turn these two off. And that is a copy of this. So it's one piece. Okay. So now if I go over here and I'm looking at the top, yes, 3D roughing, because I've added this, it's going to change everything in here, recalculate, reset my preview, and go over here and recalculate. Now, when I preview all toolpaths, yeah, I needed to bring that down. That model height was too high. It stuck up over the top. But we'll look at the time. Now we've added another 13 minutes. Martin brings up an excellent point, and let me fix this because I don't want to leave it looking like that. Reset preview. Go over here. And, well, no, I don't have to do that. Yeah, I don't have to do that. I can come over here into material setup, and my model thickness exceeds material thickness. I'll set this height. No, I don't want to scale both sides. I want to set this height to 0.75. Apply. Zippity dadu, close. Okay. Recalculate. Okay. Now let's go back here. We're looking at the top. Now let's preview the toolpaths. There we go. That's much nicer. So it does add time. Okay. It does add time. But it also is dependent on the size of the bit that you're using. Okay. I'm using the 1/8 inch tapered ball nose. Now, Martin Pearson brings up an excellent point here. You could use rest machining for this project. And what that is, close, we'll go into the finishing toolpath, and I'll add another bit. For this, I'll go use my let's see, I'll use my 1/16 inch tapered ball nose. And so now I'm using both bits. Calculate. And what that's going to do is, let's reset the preview. That's going to use that 1/8 inch ball nose to come do this entire model. then when that's done, that 1/16 of an inch bit's going to come around and just do these little areas that 1/8 inch could not reach. So now when I uncheck and we preview all tool paths, there's the roughing, there's the first finishing, and there's the final finishing. Much better detail. And again, I'm using the lowest resolution. I'm using the lowest resolution just to speed up this preview. Close that, and let's go select all tool paths. We're looking at, we're looking at top and bottom though, I think. Yes. Yes, this one here, 3D Finish 2. We've added quite a bit of time. So we're looking at, let's select just these 3. We're looking at 2 hours. So we've added quite a bit of time. Okay. That's because we've reduced the size of that end mill. Now, let's take a look at that, and you'll see why. We get into this tapered ball nose here. The tip of it is only a 1/16 of an inch in diameter. And we're looking at our step over of 8%. That is 5/1000ths of an inch it's stepping over every time it makes a pass. Okay? That is not very much. For my metric compadres, that is that's about 1/8 of a millimeter, 0.127 of a millimeter. So that'll show you how small that is, that it's stepping over. So if it's a fairly small dish, that won't really add up all that much. But if you're looking at something that's 10 inches in diameter, that is huge. Okay. I mean, that's going to take a lot of time. Figure 10 inches at 5/1000ths of an inch per step. That's what takes so long. Feed rate and plunge rate, if you're doing a roughing pass, generally speaking, we can go ahead and increase the plunge rate to the same as the feed rate because it's not removing much material at all. So then we calculate that and we'll see what that did to the, close that. The preview is going to look the same. And let's just do these 3 only. We're still looking at 2 hours and 11 minutes. Now, 3D carving, it just takes time. And there's no way of getting around that fact. It takes time. That's why it is so difficult to price and to sell 3D projects. If you're making this for you or as a gift, then, the time is less of a concern. If you're making these to sell, you've got 2 hours and 11 minutes into the lid of this dish. We haven't even talked about the underside of the lid, and we haven't talked about the dish itself. So you may end up with 10 hours into a project. Well, let's figure, personally, I think machine time is criminally undervalued these days because so many people have CNC routers. There's a lot of competition out there where there didn't used to be. But if you figure $40 an hour for machine time, which is low, that's still 10 hours. That's a $400 dish. And that's just for the machine time. We haven't gotten into materials. We haven't gotten into the prep. We haven't gotten into sanding and finishing. We haven't gotten into any of that stuff. So you may be looking at a $500 or $600 dish here. That's why it's so hard to make money on 3D carvings, because it may be worth every penny of that $600, but you have just reduced the number of people who are not only able to, but are willing to pay that kind of price. So it's, you're either going to compromise your time that you put into all this, or you're going to compromise on quality. And if it's your name going on it, I don't think you want to do that. But so it has to be a compromise in price as far as machine time goes. Now, a lot of people don't really care about that. They say, well, I'm not doing it, the machine is, and I'm doing something else. True, but every minute your machine is running on that project is a minute it's not running on another project. So it does add up. So you're using a 6mm tapered ball nose. Is that the shank diameter or is that the cutting diameter? You know, the tip diameter. So I hope that kind of helps you out, Sam. It's kind of there's a lot of give and take when it comes to doing 3D carvings. And one of the things that, you know, as you alluded to over here, is the finishing time. 3D carving just take time. The longest I have ever heard of was a gentleman who was over in Europe, and I really don't remember his name. But he was talking about one file they did at his company that was like 26 million lines of G code, and the carve took 54 hours. Now, this is on an industrial CNC machine, a 54-hour carve, and they ran it 10 hours a day for 6 days to get that one carve done. And believe me, the client paid, and paid heavily for that project. And this has been, you know, 5 or 6 years back. So, you know, yeah, it's hard to make money on 3Ds. Jim Brown says that's why he went to inlays. Yeah. You know. Um, uh, Sam, get into your feeds and speeds. If you're doing a roughing tool path first, that's going to leave a lot less material for that tapered ball nose to go through. And you can remember one rule of thumb. Your CNC router always moves at the rate of the slowest axis. And that's one reason why 3D machining takes so long, because your Z is in almost constant motion on a 3D carve. And there it is right there. Let's go into my eighth inch tapered ball nose. The feed rate of my tapered ball nose is 100 inches per minute. But my plunge rate, that's how fast the Z is going to go up and down, is 50 inches per minute. So on a 3D carve using this tapered ball nose, this feed rate is irrelevant because it's going to move at the rate of the slowest axis. In this case, it's my Z. So while it's doing that 3D carve, it's going to move at 50, not 100. I could set this to 1,000. It's going to run at 50 inches per minute. So if you do a roughing toolpath and leave a small amount machining allowance, I can in this case, for this project, I would bump that up equal to the feed rate. So that would work. Okay. Now you're talking about a 6 millimeter ball nose. That's roughly slightly smaller than a 1/4 inch ball nose. And for that, I wouldn't even use a tapered ball nose. I would just use a 1/4 inch regular ball nose bit. Even that is way too slow. That 1/4 inch ball nose can go a lot faster than that. I'll just use 100 as an example. And I typically set my plunge rate to half of my feed rate. Click apply. On this 3D carve, I would set my plunge rate to be equal to my feed rate. So now A10 Tall channel member says, I do 3D carves all the time. For me, it's the slow acceleration that's responsible for the slowdown, not so much plunge rate. That's in your CNC router settings. That's in your controller settings. When I got my Avid, it was set by the factory at, it accelerated at the rate of, what was it, 50 inches per second. That's taking off quick. And it was too quick for what I do because I tend to do small things. And that rapid of acceleration was just too fast. I slowed it down to 25, and I'm getting ready to slow it down to 20 because even then, that's a little bit too quick. By comparison, my Gatton CNC, I had it set to 4, but it was a lead screw driven machine. It wasn't rack and pinion like the Avid. The Avid is capable of moving faster. That ball screw, or excuse me, that lead screw driven machine wasn't capable of that rapid of a acceleration. Because when you think of even 4 inches per second, that's pretty quick. 50 inches per second is, I mean, that sucker is accelerating faster than your car will. So, let's see. Brooks Martin says one speed up trick I have yet to muck with is set the feed and plunge rate equal for the 3D finishing toolpath. That's generally speaking what I do, Brooks, on the finishing toolpath. If I've done a roughing, if I haven't done a roughing toolpath, then I won't bother. I don't mess with it. So. Okay, let's see here. It's been helpful. Thank you so much. You're welcome so much. And I have talked about this in other videos, but I wouldn't know which ones. Not off the top of my head. So, okay, let's jump out of the screen here. And let's see what we got going here. Robert Dymock wants to know, have you done anything with vacuum holding? No, I haven't. Not yet. I don't have a vacuum table. I've been thinking about making a couple of vacuum pods to mount in my work location just for certain projects, but I haven't explored it yet. And there's a lot of info out there on the net and on YouTube about vacuum tables and vacuum pods, but I haven't dipped my toe into that pool yet. I might be pretty soon. So Let's see here. What else do I have here? Midnight Rider Blue Man, okay, wants to know, how do I import a photo or drawing from my gallery to the picture gallery on the CNC programming for bitmapping? Okay, I have done a couple of videos on bitmap tracing, and I'll link them in the description when we get done live here. But in a nutshell, let me go ahead, and I just wrote myself a note. That's what I was doing. Let me go ahead and do a real quick and dirty screen share here. We'll have to go ahead and get rid of all this stuff. Let's go ahead and delete all that, and we'll go back over to the drawing tab, change back to a single-sided job. Okay. This is an irreversible operation. Yes. Okay, we're done. Basically, in a nutshell, importing a photo or drawing. Now, some photos are just not going to translate well. They're just not going to do very well at all. Not every photo can be bitmap traced. Some can, some can't. Basically, look for line drawings, look for coloring page books, coloring book pages rather, clip art, things of that nature. You'll come right over here to this icon, Trace Bitmap. But first you'll have to import a bitmap, and that's this icon up here under File Operations, the last icon on the top row. Import a bitmap, and it will take you to wherever. I don't have any bitmaps here to import, so I won't. You'll import the bitmap. I don't resize until after I have done the bitmap trace. You'll import it into the software, then get into tracing the bitmap. As I said, I've got a couple of videos. In fact, I'll put a link to the playlist of my bitmap tracing videos down in the description of this video as soon as we're done live. Okay. That would be the easiest way to go because it's more than we can cover here. You will also need to get into node editing. And node editing can be an art of its own, but you will need to move nodes and join vectors and cut vectors and everything else. And that's incorporated into the first video I did on this subject, where I showed importing, then bitmap tracing, then node editing in order to carve the photo. I also did another video where I showed how to Vcarve open vectors. And that was a big help as well. So I'll put all of those in there down in the description of this video as soon as we're done live, because it's way more than we can cover right now. I mean, each video is about a half hour long. Let's see here. Chris wants to know, can you Vcarve in Pine without the furring that appears on the top edges of the letters? It's difficult. It's difficult. Softwoods are sometimes harder to carve than hardwoods because of that. One thing to look for when you are shopping for the materials is look for flat sawn material rather than quarter sawn. Flat sawn materials are easier to carve. It's a completely different look, but let me see. Do I have anything here? Since I cleaned up my act, I don't have anything here. This is flat sawn. So this piece of birch right here is flat sawn. And you can tell by looking at, and you're not going to be able to see them. Well, you can kind of. You can see the annular rings are arced like such. Okay. You're going to get a lot less tear out here on this surface than if you're using a piece of quarter sawn material, and I don't have anything quarter sawn right here handy, where the growth rings are almost vertical. You're going to get a lot more tear out there because the wood fibers in between those annular rings is softer than the annular ring itself. And it will look like the bit is trying to plow its way through the material rather than cut it. You also will have to slow down your feed rate slightly to give bits time to cut rather than tear. If you try to run a real fast feed rate, 150, 180 inches per minute, it's going to try to tear as it forces its way through. Okay. If you are talking about, feed rate of 42 inches a minute. Okay. Using a 60 and 90 degree V-bit had the same result with pine also. I'm going to address that when I Vcarve my tiling project because I'm using cedar. And as a softwood, you are going to get some tear out, but there are steps you can take to help alleviate that. Number one is make sure that puppy is sharp. Make sure that bit is sharp. Now, you can, let me grab a bit here. And this is why I don't do live streams in my pajamas. I got to get up. Uh, you didn't want to know that or need to know that. I just grabbed a 90-degree V-bit here for no particular reason. If you've got the type of V-bit that has the carbide inserts, okay, like this, So this is what happens when you lose internet. Well, what a revolting development that was. Um, let's see. Am I live? Am I back? Let's see here. Um, don't know. Am I da 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 da. He got stuck. Okay. You froze, frozen. Actually, no. What happened was all of a sudden my internet said, "Yep, show's over. I'm tired." So I had to go in the house, reset the router. I'll be buying a new router next week, by the way, and come out here and wait for it to decide it wanted to do its job. So sorry to leave everybody in suspense there, but I see y'all have been having a good old time. What happened was my router decided to take a break. I don't know. So let me go back up here and get back to where I was talking about dressing up this type of carbide insert bit. If you go to the flat side here, don't mess with the bevel. But if you go to the flat side here, I take a diamond plate that I use. I basically I use it for flattening my whetstones for sharpening. I take a diamond plate and just gently dress that up to remove any kind of nicks or burrs, and it reestablishes that nice sharp edge. Make sure the bit is sharp in pine, fir, cedar, things like that. Um, let's see here. Jeff Woody One says downcut V bit might help. Yes, a downcut V bit will work. Will work very well. Um, uh, I have a set coming from Cadence Manufacturing. So Chris says, I was so glued to the monitor. That's the exact V bit I was using. One of these CMT jobbies. CMT makes a good bit. I know a lot of people get stuck on Amana and Vortex and Unsrud and various others. And CMT makes a good bit. Um, Mario is talking about seal the surface with epoxy uh, or another sealer that can help. Um, Martin is talking about sanding sealer can help, but it depends on the depth of the carve. That's another big factor. Um, basically put, um, okay, I do a lot of my 3D carves in pine. 3D carves are a little bit different because you're removing so much of the material. You're basically not leaving any of the surface. It's around those outside edges. And when we're doing a 3D carve, usually we're doing a profile to cut that part out. Not always, but usually we're doing a profile to cut that part out. And when we're not, like for instance, on a dish of some form, if you've got a figure, a galloping horse in a dish, you're coming up to those edges and you're removing that splintering. So that's a big help. Um, you guys are stealing my thunder, and I love it. I love it. A double carve might work for you. First pass with a slight positive Z offset. Second carve is final carve with zero offset. Basically doing it in a couple of stages. So you're taking off the majority of the material with the first stage, and then you're coming back that last final little bit and trimming a lot of that off. That helps as well. Um, Chris says, I just got pine because it was cheaper and I'm still new to this. Perfectly legitimate. Figured use up that wood to experiment and learn. Perfectly legitimate. When I was learning my machine, and I still do it, um, I used heck out of fence boards. You can usually go on to your local Craigslist or Kijiji or even Facebook Marketplace, go to the free section, and you will usually find scrap wood that people are throwing away. And that is the perfect material to practice on. And you might be surprised. You can find some pretty good woods that are destined for the landfill that you can save/salvage. And I have no philosophical problem at all with carving up something that was headed for the landfill. I do have a problem with buying $100 worth of maple and then screwing that up. But you would be you would be amazed at some of the stuff that people just throw out. I mean, I've got a cherry cabinet. I got two cherry cabinet doors in my other shed that somebody was just chucking. Anybody wants these two cabinet doors, go for it. They're raised panel doors, but those raised panels, that's cherry. Heck yeah. I'll take it, you know. Um, John Thompson says Cody's downcut bits work fantastic. He's talking about Cadence Manufacturing and Design, the manufacturer of the Jenny bit. And he's just getting some of these bits into production. Some of them are out, they're released. I will also put a link to Cadence Manufacturing and Design's website down in the description of this video. Hashtag not sponsored. Um, I'll put a link as soon as we're done live here, for real. Not if my router decides to say goodnight again. So let's see here. Yeah, I assumed it was internet down since Linda didn't say anything. Yeah, that's exactly what it was. This router, I've been gonna replace it for months now. It just, not every week, but almost always on a Sunday, and usually at about 9 o'clock in the morning, it just decides, nah, break time, and nothing. Well, I should have known it today because it didn't do it. I should have known it was going to do it at the worst possible time, and it did. Steve, the man, the myth, the legend, there it is right there. There's the link to Cody's website. Um, he's a heck of a guy and just a decent human being, a real nice guy. And he makes some good bits. So check him out. Again, hashtag not sponsored, but he knows what he's doing. Let's see here. Rob says you were much calmer than I was in my last live when my mouse got a mind of its own. Well, just what are you going to do? I mean, I'm kind of choiceless, so what the heck. Now, we had a couple of other questions up here. Sam Astuto says, I have one more huge question for you. Is there a way to add a tool changer to a C machine? Is there a product out there? You're right about it being a huge question. Automatic tool changers are, generally speaking, pretty machine specific. Okay. There's a lot of engineering that goes into them. You have to have and it's also an expensive proposition. You have to have a spindle that will take a tool holder. There are pneumatics involved, uh, and each tool holder is price pricey in itself. You need to have sensors for the tool changer to touch off to set Z height. Um, Generally speaking, a uh, stationary sensor, a let's see, a spindle made for tool changer, tool holders, a tool holder for each tool you're going to put in the rack. You have to have the rack. You have to set up a bunch of macros in your control software. This is not, unless it's machine specific, this is generally not a buy one off Amazon and it's a plug and play system. This is something that you're generally going to have to engineer on your own, unless there is one made for your specific machine. Okay. Something like ShopSaber, ShopBot, they, I believe, have automatic tool changers that you can purchase. But we're talking pretty high-end machines. I don't know if Legacy offers an automatic tool changer. I don't know if Laguna does. But you're talking about a pretty expensive proposition. If there is a website out there, it's a message forum called the CNC Zone. If you just Google CNC Zone, go over there and just search for automatic tool changer or ATC. You will see the trials and tribulations of people building automatic tool changers. I'm a damn good engineer. I'll do some research. Well, you're ahead of the game on that score, because there's a lot of stuff involved. Chris says an ATC is $2,000 to start. I thought it was more than that. I thought it was closer to $3,500. Now, if you're engineering and building all the parts yourself, yeah, I can see that. But it's more than just buy a rack and here we go. Steve is on top of it. See, this is why I keep singing this guy's praises. I mean, I didn't ask him to do any of this stuff, but he's right there. So thank you, Steve. I appreciate that. Let's see. So you're looking at a pretty significant investment, is what I'm getting at. You know, it's not just $99 on Amazon. I wish. If it was, everybody'd have one. Okay. Brooks Martin says, have you used shellac before Vcarving to minimize the fuzzing? I have tried it. And I'll be honest, I didn't notice a heck of a lot of difference. I tend to look more at grain orientation and look at bits. Now, when we were talking about using a V-bit in Pine, you answered my question before I got a chance to ask it. And that was, what type of bit are you using? If you're talking about a plain end mill, for Pine, a downcut will get rid of that fuzz. A downcut end mill will do it. If you're talking about V-bits, where it's basically a straight cutter, there's no spiral to it at all, it's catch as catch can. You've got to do a lot of finessing. Now, I see somebody back up here said something about poplar. I find poplar to be very close to the same as pine. In fact, even worse. Poplar is very stringy, and it tends to rip and tear more than it does for it tends to rip and tear more than it cuts. There are things you can do to alleviate that. And one of those things is using ridiculously slow feed rates that will get you laughed out of just about every CNC group or forum you'll find. And I'm talking about something goofy like a 14,000 RPM with like an 18 inch per minute feed rate. And I got that recommendation from Michael Tyler. If you don't know who Michael Tyler is the guy who creates all of Vectric's free monthly projects. So if you had, well, not all, almost all, there's one or two that he didn't design and make. So if you have made the Vectric Paradise box, he's the guy that designed that and made the first prototypes of that. And if you have Vectric software and you haven't made a Paradise box yet, number one, shame on you. Number two, get over there into the free projects and download it and cut one. I mean, they're awesome. I made them for my granddaughters for Christmas one year and they absolutely loved them. So, but getting back to that, I asked him for a recommendation because he cuts a lot of poplar and he paints it for a lot of his projects. And the guy is just a wizard when it comes to painting 3D art. I mean, he's just amazing. And he's the one that told me, it's ridiculous, but this is the cleanest cut you're ever going to get out of poplar. And that is to use like a 14,000 RPM and like 18 inches per minute. And I tried it, and sure enough, it worked beautifully. It cut like butter. But you're also translating that into very slow carve times because that's not very quick at all. That's getting down into metal machining territory, So, um, Jack in the shop says I use a clear coat before Vcarve to paint, then paint fill the carve, still have a little fuzz. Yeah. I mean, I don't know that there is any perfect answer to that. It's just a lot of steps to help mitigate a lot of it. Something that I have found, now this doesn't help a lot with tear out on edges. It can, but not quite. Something that I have found that can help clean up a bad V-carve is just running the G-code twice. And I know that's, if you've got a 2-hour carve, it's like, are you kidding me? Run it twice? I mean, it's your choice. But I have found that on shorter carves, if I'm having a little bit of an issue, like just a name on something, I'll run it twice. And that will generally clean out whatever the first run missed. And the reason the first run missed it is because I was pushing it too fast. I was going for too high a feed rate. So sometimes you got to do what you got to do. But just overall in general, sometimes slowing down feed rates gives you a better final result, which is, after all, the whole name of the game. And sealing beforehand, be it with shellac or lacquer or epoxy or something else, that's a viable option. But I would highly recommend that you seal with something that's compatible with the top coat finish that you're going to use. If you're going to use epoxy, then seal it with epoxy. If you're going to use a lacquer top coat, then use a lacquer to seal it, or a lacquer-based sealer. If you're going to use shellac, shellac is pretty much neutral. You can put lacquer or varnish over shellac. It's a universal sealer. A lot of people will argue with me and tell me you'd never put polyurethane over shellac. Well, I've been doing it for 50 years, whatever. Everybody has an opinion on that. If you do it right, it's just fine. All of that will help, but it won't cure it. So, let's see. George Navarre says, I think using a tool changer is showing laziness. Come on, George. Let's be honest with ourselves. Using a CNC is showing laziness. I mean, and yes, as Chris points out, they're generally for production. Yeah. So, hey, but again, we all get off the elevator on our floor. So if you want to speed it up, and let's face it, they're cool, man. Sometimes just the cool factor is enough. If If you want an automatic tool changer, I'm not going to tell you not to do it. If you don't want an automatic tool changer, I'm not going to, I mean, I don't have one. And there are a couple of people doing the engineering. I know on the Avid CNC forum, they've got their automatic tool changers up and running and are working with them just fine. But Avid themselves doesn't sell an automatic tool changer for their machines. So it's one of those things that's very cool to have and real impressive, but I'm just for my setup, there are other things I want long before I want an ATC. So, yeah. I mean, the cool factor. Come on, Chris, it's a robot, you know? And what's not cool about that? That's half of the fun of owning one of these. So, my just on a totally unrelated, apropos of absolutely nothing note, I have a neighbor 2 houses over who hates this new shop because he can't hear the CNC. He hates this CNC even more because it's a spindle, it's not a router, it's not as loud. When I had the old shop, I had the door open all the time because it was too hot to work in there. And every time he heard me fire up that CNC, he'd come busting out of his house just to stand there and watch it. He was like a 5-year old. I mean, and I kept trying to tell, look, I can help you build one of these. Nope, I just want to watch yours. I don't want one. I don't want to get into it. I don't want to learn about it. I just want to watch yours. I mean, they're just cool. That's all there is to it. So, that was absolutely come from out of nowhere. For the new folks who just showed up, let's go ahead and wrap this up. For the new folks who have showed up recently, uh, my Oregon family here, I am going to be at the Black Sheep Gathering at the Lynn County Expo Center in Albany. I'm going as a spectator. I'm not presenting anything. At the Lynn County Expo Center in Albany this coming Friday, the 23rd. I will be there with a pocket full of stickers and wearing a logo T-shirt, so you'll be able to spot me. My wife and I are going up for the day. We're just gonna go check out the all the woodworking and the spinning and weaving and stuff like that. And I'm telling you, if you go look at some of this stuff, there are some amazing ideas for woodworking projects. I mean, just awesome stuff. And if you look at the price of some of these things, be thinking, man, I could make that for a lot cheaper and sell them. Yeah, you probably could. You probably could. So I'll be there. Hope to see some of you drop by and say howdy. Um, Next week, for sure, is the designing and tool pathing portion of the tool path tiling project that I have up on the bed, ready to get going. And I won't go through drawing out the entire design, um, but I will show you how to arrange the design for tiling and then tool pathing and then tiling those tool paths, then saving the G code. And then in the next video to follow, we'll come out here onto the CNC and we'll actually cut it, and I'll show you all of that stuff in action. So that'll be next week, the design portion. Channel members, we took a little unofficial poll, and we're going to talk about toolpath tiling tomorrow on the members only live stream. So don't forget to hit the community tab for the link to the members only live stream, and see you tomorrow evening, 5:30 Pacific, 8:30 Eastern. If you're not a channel member or you don't know what I'm talking about, hit that little join button down there next to the subscribe button. Panel will pop up, a video will play, tell you all about channel membership. Then you can join us over on the members only live streams, and we'll give it a go and have a lot of fun. Real quick, Chris is asking, who did you say had free projects? Vectric? Yes. Go to vectric.com, log in. There's a big link right there. Log into your V & Company account, then click free projects, and there's about 10 pages of them. And the Paradise box, I think, is all the way on the last page. But there's a whole bunch of cool projects along the way. So, and that's for all Vectric customers. Those are free to download. All the files are there, tool paths. You just need to recalculate the tool paths for your tools and your machines, and you're ready to go. So, with that in mind, channel members, I'll see you tomorrow night. Everybody else, I'll see you next week. And I normally say, go do something cool, go get out in the shop, but it's Father's Day. Park yourself in front of the TV, have a cold one, enjoy. You've earned it. It's your day. Y'all take care. And thank you for hanging with me with the internet problems. Bye-bye. See you next week.